In Kubernetes environments, resource overprovisioning remains a persistent challenge. Only 10% of CPUs and 24% of memory are typically utilized, and a staggering 39% gap exists between provisioned and requested CPUs. These inefficiencies translate to wasted cloud spend, underutilized infrastructure, and operational complexity. This keynote dives into how automation, through intelligent rightsizing, real-time autoscaling, and automated workload management, can drastically reduce this gap. Our speaker on the keynote, Gaurang, is a regional field CTO at Cast AI, specializing in helping customers optimize their Kubernetes spending. With over 12 years of experience across startups, product development, and consulting, Gaurang has a strong background in data science, blockchain, and DevOps. Previously, he served as a principal solution architect, bringing deep technical expertise to innovative solutions in cloud and infrastructure optimization. Welcome, Gaurang Singh.
Good morning, everyone. Myself, Gaurang. I think I got all the introduction which I need, but yeah, I manage APAC region as a field CTO role. Today's topic is closing gap, and actually, we want to understand where the gap is, right? So we did a study. This study basically, we collect data between 2,100 customers across the landscape, startup to big enterprise, where we actually collected data. And this study had good parameters, right? The customer base was 2,100, and we took clusters which are more than 50 CPU. So the sample set has big enough CPUs to consider, and we have across all the clientele, right? So what we did is we capture the data when they connect a cluster with us, right? And this data set is for 1 year. So the very first and interesting point we found is only 10% of the actual CPU provision is being utilized in the system. When I say provision, so that three terms I'm going to use a lot. One is provision CPU, which is what you pay for, right? The number of CPUs. If you guys using Kubernetes and you are in the journey of FinOps, the very first thing you basically draw a graph of is how much of the CPU you have in your system and what you are paying for, right? And the second baseline is what your application actually wants, right? So that is called requested CPU or application allocation CPU, right? So both are the same term. If you go in more technical, it's a requested CPU, but in general term, we say allocation CPU. And the third is the actual usage, right? Your application use. What is the application use? You guys have all the laptops you have, right? You all have opened your laptop and checked what is the CPU utilization look like, right? But for that laptop, you already paid for it, even though it is 16 CPU. No matter, it's a kind of on-prem setup for you, right? But in a cloud environment, it's flexible. So you can actually, as per your usage, you can increase and decrease the cloud footprint, and that's how you pay to the cloud provider. It's a renting system, right? So the data what we have, and we found very astounding that whatever the CPU customers have provision in their Kubernetes environment, only 10% is actually used. So they're paying 10x of their actual usage. That's a general trend in the system. Memory is slightly better. So for memory, we have 24% utilization. So slightly better, but it's still not as worse as CPU. And mind you, CPU is 80% the cost of your machine. So if you purchase one machine, 80% of the cost is CPU, and rest is basically memory, right? And the third interesting data point is 39% is the gap between what you provision, actually what you pay for, and what you request is your application defined for. And there's a huge gap in between what you use versus request. So these three data points we get. So let's understand what are the three culprits we have here, right? The very first culprit is overprovisioning, and it's a complex problem, right? Overprovisioning means you have set up your autoscaler and you basically end up having lots of resources and computes in the system. Second main reason is unwarranted headroom. So your unwarranted headroom is basically your application developer is deploying an application and requesting some CPU, right? So they say that my application need 2 CPUs, and that's why they configure the application and deploy it. It is not always the same case, right? So the humans are basically have habits. They basically understand that, at one point we did it, and that's how they set up. The third is expensive machines. So how to solve this problem? Automation. Automation is the key. Let's understand what automation results. So this is the fine close gap between what you basically need and what's your provision is very, very close gap. So I quickly take one example here. So this is before automation, right? So blue line is what you're paying for, right? It's the provision CPU, and basically the yellow line is what your application need. And there's a huge gap between, right? And the white space between is what you're wasting, right? You're paying to the cloud provider, but you're not using it, right? And once you enable the automation, here is what we got. It's closely following your utilization. And that's how you basically reduce the waste. And once you reduce the waste, you basically end up paying what you actually need, right? How to find better instance? So this is the one example where we do rebalancing, where we find better instance. So you have in the left side what you have developer setup, but your application doesn't need those, right? So what we did, we asked an agent to analyze the workload, find better machines, better configuration. What is the difference? Here in the left side you are paying around $4,000 plus per month. In the right side you are paying around 1,400, right? It's an effective, I would say 67% reduction in the cost by just picking right machines for the right workload, right? And the last option what you have is slightly controversial, is spot nodes. And people do not understand the utilization of the spot node, and they feel very fear that if they use spot nodes they get a downtime. But in Kubernetes world, when your systems are agile, your applications are agile, you basically can leverage spot nodes if you have a better handling system. And that's what you can do here. You almost save 40% cost of your entire cluster. Not migrating the full cluster, but the one which are compatible with the spot nodes, you can actually reduce your cost by 40%. That's it for me for today. Thank you so much. Thank you.
Thanks, Gaurang. Thanks for breaking down that hidden cost in Kubernetes environments, especially the striking gap between provisioned and actual usage. That probably hit home with a lot of our attendees. I request Prakash to join us on stage to facilitate Gaurang. Thanks, Gaurang. Thanks, Prakash. Thank you, team.